Before we can understand our place in the universe, we have to understand the galaxy we call home. The Milky Way looks peaceful from Earth, a pale river of light stretching across the night sky. But appearances are deceptive. Behind that familiar glow lies a dynamic system shaped by gravity, time, and unimaginable cosmic forces. Our galaxy is more than a collection of stars. It is a vast structure containing hundreds of billions of stars, enormous clouds of gas and dust, mysterious dark matter, and one of the most powerful objects in the universe hidden at its center. For billions of years, the Milky Way has been changing. It has grown by capturing smaller galaxies, absorbing their stars, and reshaping itself through repeated gravitational encounters. The galaxy we see today is the result of countless ancient mergers that unfolded over billions of years. One of those mergers is still happening today. A small companion, known as the Sagittarius dwarf galaxy, is slowly being torn apart by the Milky Way's gravity. Its stars are being stretched into enormous streams that wrap around our galaxy, becoming part of its future. Our next great encounter has already begun. The Andromeda Galaxy is moving toward us through intergalactic space. Although it is more than 2 million light-years away, gravity is slowly bringing the two giant spiral galaxies together. In several billion years, they will merge into a completely new galaxy. Surprisingly, direct collisions between stars will remain extremely unlikely because the distances separating them are so immense. Instead, gravity will reshape both galaxies into an entirely different cosmic structure. The Milky Way is not simply surviving, it is constantly evolving. Some of its oldest stars are even older than the galaxy itself. Astronomers have discovered ancient stars whose chemical composition suggests they formed inside small primordial galaxies shortly after the Big Bang. Those galaxies later merged with the young Milky Way, carrying their oldest stars into our galactic halo. These stellar relics preserve a record of the earliest chapters of cosmic history. Every star carries a unique chemical signature. By studying these fingerprints, scientists can identify where a star was born, whether it formed inside the Milky Way or arrived from another galaxy billions of years ago. In many ways, the Milky Way resembles a living archive. Every orbit, every stream of stars, and every ancient cluster preserves evidence of events that occurred long before our solar system even existed. Our own solar system is also traveling through this immense structure at extraordinary speed. The Sun races around the center of the galaxy at more than 800,000 kilometers per hour. Yet one complete orbit takes roughly 225 million years. That means, since the birth of the solar system, the Sun has completed only about 20 journeys around the Milky Way. When the first dinosaurs appeared on Earth, our solar system occupied a completely different region of the galaxy. Even at this very moment, as you watch this video, Earth, the Sun, and every planet are moving through space together on a journey that began billions of years ago and will continue for billions more. The Milky Way is not a frozen picture in the sky. It is a galaxy in motion. And what we have discovered so far is only the beginning. If one of these facts surprised you, tell us which one in the comments. There are many more remarkable discoveries ahead, and the next chapter reveals how our galaxy is built from structures we cannot even see. To understand why the Milky Way behaves the way it does, we first need to look beneath its beautiful appearance. From Earth, our galaxy seems like a graceful spiral painted across the night sky. In reality, it is an enormous gravitational machine whose structure is far more complex than astronomers once imagined. One of the greatest challenges is that we cannot step outside the Milky Way to photograph it. Every map of our galaxy has been built from billions of observations collected from inside the disk itself. Imagine trying to draw the shape of an entire forest while standing between its trees. Dust clouds block our view, distant stars overlap, and many regions remain hidden behind enormous curtains of gas. For decades, scientists believed the Milky Way contained 4 large spiral arms. Modern observations have revealed a far more complicated picture. Some arms split into branches, others fade before reconnecting farther away, while smaller structures weave between them. Rather than a perfect spiral, our galaxy appears to be constantly reshaping itself. Our own solar system occupies a relatively quiet neighborhood called the Orion Spur. This small bridge of stars lies between 2 much larger spiral arms known as Sagittarius and Perseus. Compared with the crowded central regions, our location is unusually calm. Massive stellar explosions are less common here, and this stable environment may have given complex life on Earth enough time to develop over hundreds of millions of years. The spiral arms themselves are not permanent structures. They are not made from the same stars forever locked into place. Instead, they behave like enormous traffic waves moving through the galactic disk. Stars drift into these dense regions, while vast clouds of gas become compressed. As the pressure increases, gravity takes over, and new stars begin to form. This is why spiral arms shine so brightly. They are filled with young, hot, blue stars that have only recently ignited. These brilliant stellar nurseries illuminate the galaxy like glowing rivers stretching across space. Every star, including our own sun, was born inside one of these immense molecular clouds. These clouds are among the coldest places in the universe. They are composed primarily of hydrogen, mixed with tiny particles of dust. Although they may span hundreds of light years, their temperatures remain only a few degrees above absolute zero. Hidden deep inside these dark clouds, gravity slowly gathers material into denser regions. Over millions of years, those regions collapse until nuclear fusion begins, giving birth to entirely new stars. Some of these newborn systems eventually produce planets. Others may never form stable worlds at all. Across the Milky Way, billions of different planetary systems are likely following completely different evolutionary paths. Yet the visible stars represent only a small fraction of our galaxy. Surrounding the entire Milky Way is an enormous invisible halo extending far beyond the spiral disk. Within this halo orbit, ancient globular clusters, stellar streams left behind by destroyed galaxies, and something far more mysterious: dark matter. No telescope has ever photographed dark matter directly. It emits no light, reflects nothing, and interacts with ordinary matter almost exclusively through gravity. Yet astronomers know it must exist, because the galaxy simply cannot be explained without it. According to classical physics, the outer stars should orbit much more slowly than those near the center. Instead, they move at nearly the same speed. If only visible matter existed, the Milky Way would have flown apart billions of years ago. Dark matter changes everything. Scientists estimate that most of our galaxy's mass belongs not to stars, planets, or gas, but to this invisible substance surrounding the Milky Way like an enormous gravitational framework. Every orbit, every spiral arm, and every stellar stream depends on something humanity still cannot identify. Even stranger, the galaxy itself is not perfectly flat. Radio observations have revealed that the outer disk bends upward on one side and downward on the other, creating a giant wave stretching across tens of thousands of light years. Astronomers suspect this distortion may be caused by nearby dwarf galaxies, uneven concentrations of dark matter, or gravitational interactions that continue to reshape the Milky Way even today. The galaxy also contains 2 distinct disks. The thin disk is where our solar system resides. It contains younger stars, active star-forming regions, and most of the visible spiral structure. Above and below it lies the thick disk, populated by much older stars moving along steeper and more chaotic orbits. These ancient populations preserve evidence of violent events that occurred when the Milky Way was still assembling billions of years ago. The deeper scientists look into our galaxy, the more they discover that almost every visible structure hides an invisible story beneath it. What appears calm is constantly moving. What appears permanent is slowly changing. And what appears empty is often filled with matter we cannot see. In the next chapter, we travel toward the very heart of the Milky Way, where a supermassive black hole, mysterious gamma-ray structures, and some of the most energetic phenomena in the universe reveal that our quiet galactic home is anything but ordinary. If one discovery changed the way you think about the Milky Way, share it in the comments. Which hidden feature surprised you the most so far? At the very center of the Milky Way lies one of the most mysterious places humanity has ever studied. More than 26,000 light-years from Earth, hidden behind enormous clouds of dust and gas, sits a supermassive black hole known as Sagittarius A star. Although it cannot be seen directly, its presence is impossible to ignore. Astronomers discovered it by carefully tracking the motion of nearby stars. They watched these stars race around an apparently empty point in space at extraordinary speeds, revealing the immense gravitational force of an object containing more than 4 million times the mass of our Sun. Surprisingly, Sagittarius A star is relatively quiet today. It consumes only small amounts of surrounding gas and dust. But evidence suggests that the center of our galaxy has not always been so peaceful. High above and below the galactic disk stretch two enormous structures, unlike anything scientists expected to find. These giant formations, known as the Fermi Bubbles, extend for tens of thousands of light-years into space. They emit intense gamma radiation, the highest energy form of light known in nature. No one knows exactly how these colossal bubbles formed. One possibility is that millions of years ago, the central black hole experienced a period of intense activity, swallowing huge amounts of matter and releasing unimaginable energy into the surrounding galaxy. Another theory suggests that an extraordinary burst of star formation created thousands of massive stars that exploded as supernovae within a relatively short period of time. Either explanation reveals an astonishing truth. The Milky Way has experienced episodes of incredible violence that left scars still visible across the galaxy today. The black hole is only one source of extraordinary activity. Throughout the Milky Way, massive stars eventually exhaust their nuclear fuel. When that happens, gravity overwhelms the star, triggering one of the most powerful explosions in the universe, a supernova. For a brief period, a single exploding star can outshine billions of ordinary stars combined. But these explosions are far more than spectacular cosmic fireworks. They create the heavy elements that make planets, oceans, mountains, and even living organisms possible. The calcium in your bones, the oxygen you breathe, the iron carried through your bloodstream, the gold used in technology and jewelry. Nearly every heavy element on Earth was forged inside ancient stars before being scattered across the galaxy by supernova explosions. Every generation of stars enriches the Milky Way with new material. That matter eventually becomes part of future stars, future planets, and perhaps future civilizations. In a very real sense, the galaxy continuously recycles itself. Stars are born, they evolve, they die, and their remains become the building blocks of entirely new worlds. Astronomers have also discovered long ribbons of stars stretching across the Milky Way. These stellar streams are the surviving remains of dwarf galaxies that ventured too close to our own. Over millions of years, tidal forces slowly tore them apart. Instead of disappearing, their stars continued orbiting the Milky Way, leaving enormous streams that wrap around the galaxy like faint rivers of light. Each stellar stream is a fossil record of an ancient galactic collision. By measuring their positions, motions, and chemical composition, scientists can reconstruct events that happened billions of years before the solar system formed. Some stars reveal an even stranger history. Not every star follows the general rotation of the Milky Way. A number of ancient stars travel in the opposite direction, orbiting backward around the galactic center. These unusual motions strongly suggest they were born in completely different galaxies, before eventually becoming part of ours through ancient mergers. The galaxy remembers its past, not only through light, but through motion. Every orbit tells part of the story. Some stars preserve another remarkable secret. Occasionally, astronomers discover hypervelocity stars traveling fast enough to escape the Milky Way forever. Many of these stellar runaways are believed to have passed dangerously close to Sagittarius A star. The enormous gravity of the central black hole can disrupt binary star systems, capturing one star while catapulting its companion into intergalactic space at incredible speed. These lonely travelers will spend billions of years crossing the darkness between galaxies. Far beyond the bright spiral arms, another ancient population quietly circles the Milky Way. More than 150 globular clusters orbit within the galactic halo. Each contains hundreds of thousands of tightly packed stars. Many formed more than 12 billion years ago, making them some of the oldest surviving structures in our galaxy. These clusters are extraordinary cosmic time capsules. By studying them, astronomers gain insight into the earliest stages of galaxy formation and the conditions that existed shortly after the universe itself began. Every new observation reveals another layer of hidden history. The Milky Way is no longer viewed as a simple spiral galaxy. It is a dynamic archive built from countless collisions, ancient explosions, invisible matter, and billions of years of continuous evolution. And despite everything we have learned, many of its greatest mysteries remain unsolved. In the final chapter, we leave the center behind and explore humanity's place inside this immense galaxy, what the future holds for the Milky Way, and why our cosmic journey has only just begun. If you have ever looked at the night sky and wondered what else may still be hidden beyond our view, let us know in the comments. Your question might become the subject of a future NEOSCOPE episode. After more than a century of astronomical research, one remarkable fact has become increasingly clear. The Milky Way is not a finished galaxy. It is still growing. Far beyond the visible spiral arms, streams of gas continue to flow toward our galaxy from intergalactic space. Some arrive as cold filaments stretching across the cosmic web. Others are pulled in from neighboring dwarf galaxies that wander too close to the Milky Way's immense gravitational field. This fresh material provides the raw ingredients for future generations of stars and planets. At the same time, the galaxy is constantly recycling its own matter. Powerful stellar winds and supernova explosions launch enormous amounts of gas high above the galactic disk. Over millions of years, that material cools, condenses, and slowly falls back toward the spiral arms, where it can once again become part of new stars. Astronomers call this process the galactic fountain. It is a continuous cycle of destruction, renewal, and creation that has shaped the Milky Way for billions of years. Even our own solar system is not traveling along a perfectly flat path. As the Sun completes its long journey around the galactic center, it also moves gently above and below the galactic plane, in a slow, oscillating motion. One complete wave takes tens of millions of years. Although we never notice this movement during our lifetime, it reminds us that every object inside the Milky Way is following a complex three-dimensional path through space. Our galaxy is also part of something much larger. The Milky Way belongs to a collection of more than 50 galaxies known as the Local Group. Together, they drift through the universe, held together by gravity across millions of light years. The largest members are the Milky Way and Andromeda, surrounded by dozens of smaller satellite galaxies that continue to orbit, merge, and evolve. Nothing in the universe remains unchanged. Galaxies interact, stars migrate, entire planetary systems travel across enormous distances. Even the Sun is thought to have formed inside a crowded stellar cluster billions of years ago. Over time, gravitational interactions slowly scattered its sibling stars throughout the galaxy. Somewhere within the Milky Way, many of those long-lost stellar relatives may still exist, blending into the countless stars that fill the night sky. Modern astronomy is beginning to uncover these hidden connections. The European Space Agency's Gaia mission has measured the positions and motions of more than 2 billion stars with unprecedented precision. For the first time, astronomers can watch the Milky Way almost as if it were alive. Stellar streams, ancient mergers, hidden motions, and previously unknown structures are emerging from this enormous map of our galaxy. Every new release of Gaia data changes our understanding of the Milky Way. Features once believed to be permanent now appear dynamic. Structures once considered simple reveal unexpected complexity. Questions that seemed impossible to answer only a generation ago are finally becoming accessible. Yet some of the greatest mysteries remain completely unsolved. Scientists still do not know the true nature of dark matter. They still cannot fully explain how spiral arms maintain their structure for billions of years. The exact history of many ancient galactic collisions remains incomplete. Even the total mass of the Milky Way continues to be revised as new observations become available. Perhaps the most astonishing realization is how little we actually see. On a perfectly dark night, the human eye can observe only a tiny fraction of the hundreds of billions of stars that make up our galaxy. Vast regions remain hidden behind clouds of dust. Invisible radiation fills space beyond human vision. Dark matter outweighs everything we can observe. Entire populations of stars, planets, and molecular clouds remain concealed from ordinary sight. The Milky Way is far larger, richer, and more mysterious than the beautiful ribbon of light stretching across the night sky. And beyond it lie hundreds of billions of other galaxies, each containing their own histories, their own worlds, and perhaps their own unanswered questions. Every major astronomical discovery has transformed our understanding of the universe. Each generation has believed it was close to completing the picture. Each generation has discovered an even greater mystery waiting beyond the horizon. That may be the greatest lesson the Milky Way offers us. Knowledge does not bring an end to curiosity. It expands it. Every answer reveals new questions. Every discovery opens another unexplored frontier. Our galaxy has been evolving for more than 13 billion years. Human civilization has observed it for only a tiny fraction of that history. We are only beginning to understand the place we call home. The next great discovery may already be waiting somewhere within the billions of stars surrounding us tonight. If you enjoyed exploring the hidden side of the Milky Way, tell us which discovery changed your perspective the most. Your ideas and questions help shape future NEOSCOPE documentaries. Thank you for watching, and remember, the universe always becomes more fascinating the deeper we look.